Today, I'm going to talk about a way of organizing spatial data in games, a quadtree. This structure can be used for storing destructible 2D geometry. For example, let's say we have this 2D terrain viewed from the side. You might see terrain like this in games such as Worms or Tanks. Let's also say that just like Worms or Tanks, we want to allow the player to destroy parts of the terrain through explosions. How could we represent this shape mathematically for a game to use it? Some simple options might be to store line segments that define the terrain, or even just the height of the terrain at every point. However, complications pop up with these methods when you start destroying parts of the terrain. For example, collision detection becomes difficult or even impossible. One alternative method is called a quadtree. Trees in computer science are a way of organizing data that uses a hierarchy of values. The root at the beginning of the tree branches off into child values, which each may branch off into their own child values, and so on. The ends of a tree are called leaves. We can actually apply this tree structure to 2D space to represent any kind of shape. For example, going back to our terrain, we can start by overlaying a square that entirely covers it. This large square is the root. Next, we make children by dividing the square into 4 equal parts. These are the 4 children of the root. Next, divide all children that touch the terrain into their own 4 children. Keep dividing any squares that touch the terrain surface until you get to a sufficiently high amount of detail. We could go further, but I'll stop here. Now mark each square as empty or solid. This is a completed quadtree. It's very easy for a computer to work with because it's made up of squares, which are very simple shapes. If you wanted to add explosions to your game that could damage this terrain, it's easy to modify the shape as well. Just recalculate the areas of the quadtree that were affected by the explosion. This can be done very quickly because, again, squares are simple shapes and computers are very fast.